Hello everyone, I am Ishika Patidar and I'm currently pursuing Integrated MTech IT from International Institute of Professional Studies DIVB Indore. Here I am explain about some questions of information security. This video is a part of my college assignment, so let's get started. Here, our first question is create a visual representation of the differences between the internet and the web. So here are the visual representation between internet and web. Next, what is the internet? The internet is a global network of interconnected computers and devices that communicate with each other through standard protocols such as TCP/IP. It includes various types of networks such as lanes, WANs, and the World Wide Web. And what is the web? The web is a collection of interconnected documents and resources which are accessed using the HTTP protocol over the internet. It includes various types of content such as text, images, videos, and audio files. Next. Next question is what ethical concerns are associated with using the invisible web for the data mining and surveillance purposes? The invisible web refers to the vast amount of content on the internet that cannot be accessed through standard search engines. This includes content that is not indexed or publicly available, such as password protected websites, private social media profiles, and unlisted directories. The use of the invisible web for data mining and the surveillance purposes raises several ethical concerns, including invention of privacies, unethical data collections, misuse of data, bias and discrimination, and invention of privacies. Individuals may not be aware that their private information is being accessed and collected, leading to a violation of their privacy rights. Unethical data collection. Data mining techniques may be used to collect and analyze data without the consent of individuals or organizations, leading to unethical data collection practices. Misuse of data. Collected data may be misused for purposes other than those for which it was intended, such as for targeted advertising or surveillance. Bias and discrimination. The use of data mining and surveillance techniques may result in bias and discrimination against certain individuals or groups based on factors such as race, gender, or religion. Next. Next question is how can individuals and organizations use two-factor authentication and strong password to enhance the security of their email accounts? So, to enhance the security of email accounts, individual and organizations can use two-factor authentication and the strong passwords. In two-factor authentication requires user to provide two forms of identification such as a password and a verification code sent to their mobile devices or an email address. This adds an extra layer of security and make it harder for hackers to access the account. And next is strong password should be complex and included a combination of upper and lowercase letters, numbers, and special characters. Password should also be changed regularly, and individuals should avoid using the same password for multiple accounts. Here the next question is what are the different type of malware and their impact on computer systems, and what measures can be taken to prevent malware infections, such as using antivirus software and regularly updating software. Yeah, malware is malicious software designed to damage or disrupt computer systems. Common types of malware including viruses, worms, Trojan horse, and ransomware. Malware infection can have severe consequences such as data loss, identity theft, and financial loss. To prevent malware infection, individuals and organizations should use antivirus software, keep software and operating system up to date with security patches, and avoid downloading or opening suspicious attachments or links. Next. Next question is how can individual and organization train employee to recognize and avoid social engineering techniques such as phishing, pretexting, and betting and implement policies and procedures to reduce the risk of unauthorized access to sensitive information. Social engineering techniques such as phishing, pretesting, and baiting are designed to trick individuals into divulging sensitive information or performing unauthorized actions. To reduce the risk of unauthorized access to sensitive information, individuals and organizations can train employees to recognize social engineering techniques and implement policies and procedures to prevent them. This may include providing training on how to identify phishing emails, avoiding sharing sensitive information online, verifying request for sensitive information before providing it. Next, what are some different methods of securing data such as encryption, tokenization, and access control, and how can organizations evaluate which approach best suit their specific needs? Different methods of securing data such as encryption, tokenization, and access control can be used to protect sensitive information. Organizations should evaluate their specific needs to determine which approach best suit their requirements. First, encryption. Encryption is a common method of securing data and involves converting plain text into ciphertext using a encryption algorithm and a secret key. Next, tokenization. It involves replacing sensitive data with a token that has no meaning or value, while access control involves limiting access to sensitive information based on user permission. Next, how can individuals and organizations use email filters, web filters, and firewalls to identify and block phishing and phishing schemes? And what are some best practices for responding to suspected attacks, such as reporting the incident to security teams? Email filters, web filters, and firewall can be used to identify and block phishing and phishing schemes. Email filters can be set up to block suspicious emails or to send them to spam folder, while web filters can prevent user from accessing non-malicious websites. Firewalls can block unauthorized access to computers, net systems, and networks. Best practices for responding to suspected attacks, including reporting incidents to security teams, reviewing access logs, and implementing incident responses plans. Next, what are some of the most significant milestones in the history of cryptography, such as the development of the Caesar cipher and the Enigma machine, and how have advance in technology and computing impacted the evolution of cryptographic system over time? Significant milestone in the history of cryptography includes the development of the Caesar cipher, the Enigma machine, and the RSA algorithm. Advances in technology and computing have impacted the evolution of cryptographic system over time, with modern cryptographic system using complex mathematical algorithms and key exchange protocols to ensure secure communication and data storage. Next, what are some key features and limitations of popular cryptographic algorithms such as DES, 3DES, RC4, 2FISH, and AES, and how can organizations select the appropriate algorithm for their specific use cases? Popular popular cryptographic algorithms such as DES, 3DES, RC4, 2FISH, and AES have different key sizes, block sizes, and encryption modes, which impact their security and performance. Organizations should select the appropriate algorithm for their specific use cases based on their security requirements, processing power, and the sensitivity of the data being protected. Factors to consider include the strength of the encryption, the ease of key management, and the potentials for attacks such as brute force or side channel attacks. Next, how do public and private key based crypto system work, and what are some practical applications of this system in real world scenario, such as secure messaging and online transactions? Public and private key cryptography systems work by using a pair of keys, one public key and one private, for encryption and decryption. In the system, the public key can be freely distributed while the private key is kept secret. When someone wants to send a message to the receiver, they use the receiver's public key to encrypt the message, while can only be decrypted using the receiver's private key. This ensures that only the intended receiver can read the message. Practical applications of this system include secure messaging, online transactions, and digital signatures. Next, what are some design principles such as principle of least privilege and defense in depth that organizations should follow when developing software and other systems, and how can these principles be effectively implemented using tools such as code analysis and penetration testing? Design principles such as principle of least privilege and defense in depth help organization develop secure software and system. The principle of least privilege states that each system component should only have access to the resources it needs to function, while defense in depth means using multiple layers of security controls to protect against attacks. This principle can be implemented using tools such as code analysis and penetration testing. Code analysis can help identify vulnerabilities in code, while penetration testing can simulate attacks to find weakness in the system. Next, how can organization defend against side channel attacks such as timing attacks and power analysis attacks, and what are some standard methods for detecting and mitigating these types of threats, such as using masking techniques and implementing hardware level security measures? Side channel attacks are the type of attack that targeted weakness in a system's physical characteristics such as power consumption or timing. Organizations can defend against these attacks by using masking techniques such as randomizing power consumption or adding noise to the data signals to make it harder for attackers to extract information. Hardware level security measures such as secure boot and firmware signing can also help protect against side channel attacks. Standard methods for detecting and mitigating these types of threats, including monitoring power consumption and power performing regular security audits. Next, what are some key strategies for securing Windows systems and implementing effective authentication models such as biometric and multi-factor authentication? Several measures such as following: installing regular security updates, configuring firewalls, using antivirus softwares, implementing access control, using a strong password, implementing multi-factor authentication, conducting regular security audits. Next, what standard authentication models are used by organizations such as single sign-on and multi-factor authentication, and how can organization evaluate which approach best suit their specific need, and how can organization consider which approach is best suited for their particular needs use cases? Standard authentication models such as single sign-on and multi-factor authentication are used by organizations to enhance the security of their system and data. Single sign-on allows user to access multiple applications with a single set of credentials, while MFA requires users to provide additional form of identification such as fingerprints or one-time password. Next, what is trusted computing and how does it differ from traditional security models? How can organizations leverage trusted computing technologies such as hardware-based security modules and remote attestations to enhance the security and integrity of their system and data? Trusted computing is security model that focus on the integrity of the hardware and software components of a system. It differs from traditional security models that rely on software-based solutions such as firewalls and antivirus software. Organizations can leverage trusted computing technologies such as hardware-based security modules and remote attestation to enhance the security and integrity of their system and data. Next, explain how the virus works. Explain any 10 viruses. A computer virus is a type of malware that is spread by infecting executable files or documents. Once a virus infects a system, it can perform various malicious actions such as stealing personal data or damaging files. Here are 10 examples of virus. These are the 10 viruses and their descriptions. I love you. A virus did spread via email in 2000, causing damage to millions of computers. WannaCry, a ransomware virus that affects hundreds of thousands of computers in 2017. Melissa, a virus did spread via email in 1999 and caused billions of dollars in damages. Code Red, a worm that infected several running Microsoft IIAs in 2001, causing widespread outages. MyDoom, a worm that spread via email in 2004, creating a backdoor that allowed attackers to control infected systems. Zeus, a Trojan that stole banking credentials and other sensitive information from infected systems. Configure, a worm that exploited a vulnerability in Windows system and created a botnet with millions of infected computers. Stuxnet, a worm that targeted industrial control systems, causing physical damages to centrifuges used in Iran's nuclear program. CryptoLocker, a ransomware viruses that encrypted users' files and demanded payment in exchange for the description key. Mirai, a botnet composed of infected Internet of Things devices that was used in a massive distributed denial of services attacks in 2016. Thank you.